Look up on a clear night, far from any city, and the sky looks full. Thousands of points of light. Our own galaxy poured across the dark. It looks like abundance. It is the most convincing illusion in all of nature, because that fullness is only a thin scattering of nearby light. Beyond it, almost everything is vast, cold, and empty, and the emptiness underneath is not empty. It is not even still. Something is inside it, with no light and no name we can defend, and it is pulling the universe apart. Gently. Faster every moment. We have measured it for decades. We can tell you it is winning. We cannot tell you what it is, or why it was set so precisely that we get to be here at all. Tonight we go in. For most of the last century, the story of the universe had one obvious ending. Space was expanding. Everyone agreed on that much. Roughly 100 years ago, we watched the galaxies flee from us, the far ones faster than the near ones, and we understood that the whole thing is growing. But the universe is full of matter, and matter pulls. Every galaxy tugs on every other galaxy through gravity, and gravity only ever does one thing. It reels things back in. So the expansion had to be slowing. The only question left, we thought, was how much. Would gravity win completely and drag everything back together? Or would the universe coast outward forever, slowing but never quite stopping? A tidy question. A question with two answers. The universe gave a third. Astronomers went looking for the slowdown. They found the opposite. Far across the cosmos, a certain kind of exploding star came back to us fainter than it had any right to be. And faint means far. These stars were farther away than a slowing universe could ever put them. The expansion was not easing off. It was speeding up. Sit with how strange that is. You throw a ball into the air and expect it to slow, stop, and fall. Instead, it rises faster and faster, as if the sky itself were pushing it away. Something was pushing space apart, harder than all the gravity of all the matter in the cosmos could resist. We now know it makes up around 68% of everything that exists, and everything you have ever seen or touched, every star, every planet, every atom in your body, is about 5%. Most of reality is a push we cannot see. To feel how violent that discovery was, you have to go back to the people who made it, and who did not want to believe their own data. At the close of the last century, two teams were hunting the same thing across the sky, and they were rivals. One was led by a physicist named Saul Perlmutter, working out of a national laboratory in California. The other was led by Brian Schmidt, with a young astronomer named Adam Rees running the analysis. Two groups, two sets of telescopes, two ways of doing the work, both chasing the same faint exploding stars in the deep distance. Why those stars? Because a certain kind of dying star always detonates in almost exactly the same way, releasing almost exactly the same amount of light. If you know how bright something truly is, and you measure how bright it looks from here, the difference tells you how far away it sits. These particular explosions are the closest thing astronomy has to a measuring rod you can lay across the universe. Find enough of them at enough distances and you can read the entire expansion history of the cosmos off their light. Both teams expected the same result. They expected to measure how fast the universe was slowing down. That was the whole point. Measure the slowdown and settle the tidy question. And both teams separately got an answer that made no sense. The distant stars were too faint. The universe was not slowing. It was accelerating. Rees later described the data pushing them, against their own expectations, toward a conclusion that was very hard to believe. Think about what that takes. You build your career on careful measurement. You run the numbers, and the numbers tell you the universe is doing the one thing it is not supposed to do. Your first instinct is that you have made a mistake. So, you check. And across the hall, your rivals, using different methods, are quietly arriving at the exact same impossible place. Within a single season, cosmology was rebuilt. The three men at the center of it shared the Nobel Prize, and they had proven beyond argument that the universe is being pushed apart by something. They just could not tell anyone what. So we had the fact, hard and certain. The universe is emptying faster and faster, driven by something real. What we did not have was the something. And when physicists sat down to calculate what it ought to be, they produced the single most spectacular failure in the history of their science. We gave the something a name. We call it dark energy. And you should hear that name for what it is. It is not an explanation. It is a placeholder. It is the label we put on a thing we can measure, but cannot understand. Here is the best guess we have. The push is not coming from any object. It is coming from empty space itself. That sounds like a contradiction, so slow down with me. Take a box and remove everything from it. Every speck of dust, every atom, every particle of light. Cool it down to nothing. By any ordinary meaning of the word, that box is now empty. But according to our deepest theories of how nature works, a faint energy still remains inside it. Empty space, it turns out, is never truly empty. A baseline energy belongs to it, everywhere, always. And this energy behaves unlike anything in your experience. When you stretch normal stuff thinner, spread it across more room, it gets more dilute. This does not. As space expands, the energy of empty space keeps the same strength in every cubic meter, which means the more space there is, the more of this energy there is, and the more of it there is, the harder space is pushed to expand, which makes more space, which makes more energy, which pushes harder. That is the whole mechanism. That is why the emptiness does not simply grow. It accelerates. Every new stretch of empty space arrives with its own push built in, and that push manufactures the next stretch. The universe is emptying itself, and the emptying feeds on itself. So we have a mechanism. Now, here is where a triumphant story turns into the deepest unsolved problem in modern physics. If empty space has energy, we ought to be able to calculate how much. We have the theory for it. So physicists ran the calculation. They added up what empty space should contain. The number they got was too large by a factor of 1 followed by roughly 120 zeros. I want to be honest about how absurd that is, because there is no comparison from daily life that survives it. It is not off by double. It is not off by 1,000. The amount of energy our best theory says empty space should hold is larger than the amount we actually measure by more zeros than there are stars in the observable universe. Physicists, who are not a dramatic people, call it the worst prediction in the history of science, and it is worse than embarrassing. It is a threat. Because if empty space really held anything close to the energy the theory predicts, the push would have been monstrous. Space would have torn itself apart in the first instant. No galaxies would ever have formed. No stars, no planets, no chemistry, no you. A universe with that much energy in its emptiness is a universe that flies apart before it can build a single thing worth flying apart. Instead, the real value is almost unbelievably tiny. The energy of empty space, measured, amounts to something like a few atoms worth of energy spread through an entire cubic meter of the cosmos. Enormous theory. Minuscule reality. And between them, no explanation at all. Something in nature cancels almost the entire energy away, wipes out 120 digits of it, and then, for reasons no one can name, stops just short of wiping out the last one. If it had canceled completely, there would be no push, and the galaxies would have drifted apart and gone cold on their own. If it had canceled a little less, the push would have shredded everything. It landed in the one narrow range of values that permits a universe with structure in it, with observers in it. We do not know why. We have no theory that predicts that value. We simply find ourselves living inside it. There is a strange twist here. The greatest physicist of the last century had already written a term for exactly this into his equations, long before any of it was measured. He wanted to hold the universe still, so he added a constant to push back against gravity. Then, when the galaxies were seen to be fleeing, he tore it out and called it his great mistake. It was not a mistake. It came back, and it came back carrying a mystery he never suspected. So what does this gentle, inexplicable push do to us in the end? If it stays constant, the future is a loneliness on a scale that is hard to hold in the mind. The push never tires. Every galaxy that is not already bound to us by gravity is being carried away, and carried away faster with time, one by one, over spans of time we can barely name. They cross a line beyond which their light can never again reach us. It stretches, it dims, and finally it fails. The sky empties. Far enough in the future, any astronomer who looks up will see only their own galaxy, alone in a black and silent void, with no evidence that anything else ever existed. The very light that tells us the universe had a beginning will have faded past detection. The emptiness does not just spread, it erases the record of everything that came before it. And here is the last turn, the one happening right now. For a long time we assumed this push was fixed, a true constant. The same yesterday and forever. Recently, the largest three-dimensional survey of the cosmos ever assembled, tracking the pull and drift of millions of galaxies across most of cosmic history, has started to suggest something else. That the push may not be constant, that it may have changed over time. It is not proven. The signal sits at a strength that physicists are careful to call intriguing, rather than certain below the bar they demand, before they will call a thing real. But if it holds, it does not just deepen the mystery, it reopens the ending. A push that can change is a future we cannot predict at all. So here is where the emptiness leaves us. We have measured it to many decimal places. We know it is the majority of everything. We know it was gentle enough to have permitted us, and relentless enough to eventually take the sky away. And after all of that, we cannot say what it is, why it was tuned so finely, or where it is carrying us. This is what a science looks like when it reaches the edge of itself. Not a wall, a number. The most important number in the universe, measured to many digits and explained by absolutely no one. We tend to treat emptiness as what is left over when everything else is gone. But the emptiness is not the leftover. It shaped everything. It permitted everything. It is slowly, patiently pulling everything back toward emptiness. We exist in a thin, bright, improbable window. A moment when the universe is still full enough to be seen, still young enough to remember its own beginning, still calm enough to allow us. That window is closing. Not in our lifetimes, not in a billion of them, but it is closing. And the same silent thing that opened it is the thing drawing it shut